Hello everyone, how are we doing? I hope we're doing well. So today what I'm going to go over really quickly is some of the methods that you are going to need to know from the math class. Now I go over the assignment that we did in class in another video, but this one is just to go over what the math class is. So the math class is what we call a static class, okay? That is important to know. I always do this example, and I do it in the other video as well. String x equals hello. Okay, that's one way I can do this. I could also say string y equals new string hello. Now, string is one of these special methods where I can do it either way, and they both do the same exact thing. Okay, this is basically doing the same thing that this is doing, and it's specifically only for string. So for right now, I'm just going to work with the x. I'm going to get rid of this. Now, what this means is when I've done string x, basically what Java has said, I don't want you using the string class. Instead, what I would prefer you to do is make a clone, which we've done by making an x object, and then you can go ahead and mess with the x object, and you will inherit everything that I have. That's why when we use the dot operator, notice that we get all the methods at our disposal. Okay, but the key thing was we needed to make an object out of it. Now the math class, however, is what we call a static class. And what that means is we don't need to say math y equals new math or anything like that. We can just say math dot, and any method that we need to use is at our disposal. So right now what I'm going to do is I'm going to go over the common ones that you will need to know. Okay, here we go. So the first one, absolute value. This one is really easy. And I'm just going to, rather than putting these in variables, I'm just going to use print statements. Okay, math.abs negative 72. Okay, I'm going to do this, negative 72, and I get 72. Great. I'm going to copy and I'm going to paste this, and I'm going to 72.36. Notice that it works with ints and doubles. Either one is fine. I can also do int x, or let's say int a equals negative 94. Okay, I can do variables as well, either or. Okay, boom, take a look at that, it gives me 94. The next one that you're going to need to know is the square root. Now, how do I access that? I do math.sqrt. Okay, math.sqrt. That is how we access the square root. So let's say RT, let's say I want to do of 16. You'll notice that when I do SQRT of 16, I get 4.0. Doesn't matter if I do 16.8 or 16, if it's a perfect square, it's always going to spit back a double. Remember that. It is important to remember what these methods are capable of spitting back out. Okay? Now the next one we're going to do is a power of something. Okay, to a power. Okay, we have our bases, we have our exponents. So let's say I wanted to find 2 to the third. I'll do sysout, and I'll do math.pow 2, 3. The first parameter is the base, and the second parameter is the exponent. I run it, I get 8.0. This always spits back a double as well. Okay? You also have some like math.min and math.max. I'm just going to put these here so that you can see them. I don't really need to do examples. Math.min, A and B, or math.max and A and B. Now, I want to show you an example of this in a second, but math.min, all this does is it gives us the shorter number of A, B, or C, or A or B. Now, this can be used to find the smallest number of 3 or 4, and there's a clever way to do it. So let's say I had int b equals 5, c equal 9, and d equal 4. Now, obviously, we can see this, but let's say we didn't know what the numbers were. Let's say I wanted to find the smallest. What I could do is this. I could do math.min, and I'll do b for the first variable. And then in the second one, I'll do math.min again, and I'll do C, comma, D. So what actually is going to happen now is this first parameter, or this first method, is going to find the shortest between these two. Then it's going to find the shortest between these two. Prints out 4. Do you see that? You can do this again with 4 numbers, 5 numbers. You can keep going. You can do this for a max value. It's actually very clever the way we do it. Okay? Keep that in mind because it's a very useful tool to have in your arsenal. We definitely are going to want math.round. Okay? So this is for rounding. So if I want to find out math.round, let's say 90.5. Run it. I get 91. Now the key thing to remember is it returns a long variable. Okay? This can't even be stored in an int. All you have to remember is that it does not return a number with a decimal. That's all you need to know. Okay? If I did 90.4, it'll go to 90. Perfect. Now, I want to go over math.pi really quickly before I get to the last thing. Math.pi. Now, pi is 3.14, etc. Okay, keep going. Now, Java, when the creators of Java created this, they made their own interpretation of it. In Java, in the math class, the way we call about pi is we say math.pi. Now, there's a couple things I want you to take a look at. The first is there's no parameters here. The reason why, math.pi is not a method. It is what we call a final variable. Now, variables don't have parameters. That's the key thing. But also, in Java, it's not a rule, but the standard practice is if you have final variables, they are all capitalized. Okay? Final variables can only be initialized once, which means I can never change the value of math.pi. The creators of Java did it for me. I'm just going to go ahead and go with what they've decided. And if I print it out, I only get it up to a certain point. Okay? So math.pi, again, is a final variable. Now, the last one, okay, is random. We will actually use this very often. Okay, and what I'm going to do is I'm going to say sysout math.random. And what this is going to do is it's going to give me a number between 0 and 1, exclusive of 0, inclusive of 1. Okay? Let me add something so you can see it better in my console. Here's my random number. Okay, perfect. So if I run it again, here's my random number, here's my random number, here's my random number. As you can see, it's constantly changing. Now, again, it's 0 to 1. Let's say I wanted you to do a number between 0 and 10. Well, what I'm going to do is the first thing is I'm going to say math.random times 11. Now, if I do this, there's a possibility that it could be 0 times 11, which would give me 0, and 0.999 repeating times 11, which would only give me 10 something. 2.54, 6.37, 0.02, okay, 9.42. So it is exclusive of 11, which means it's going to give me any number from 0 to 10. There's 10 right there, perfect. Now, what I now want to do is, I want to put this in parentheses, and I cleverly want to add a cast of an int. What that's going to do is it's going to force truncation. Notice now that I'm getting no decimals, and I will get any number between 0 and 10. Now, let's say, for example, that I wanted to let's say I wanted to find the number between 1 and 10. Well, if this is giving me 0 and 11, I want to change this to 10. Now this is going to give me any number between 0 and 9. But cleverly, I'm going to add 1. That means that the lowest possible number this equation could be is 0. Then I'll add 1 to it, giving me 1. The highest it can be is 9. Adding 1 will give me 10. So now there's 9, there's 1. I will never get 0. Okay, and I have the possibility of getting 10. So I would play around with this one because I can also do this for 100. 100. If I run it again, 47, 51, up to 1,000, etc., etc. There's so many different ways that we can do this. So I hope this video was helpful. These are the ones that you really want to know for the math class. Watch, 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 practice with them, and good luck.